So this is for the equilibrium constant lab. What we have here is we have the iron solution, we have the thiocyanate solution. The iron solution has been labelled F, the thiocyanate solution has been labelled S, and the water here has been labelled W. Behind each of these we have three 10 ml graduated cylinders, and we're going to use those as the as a means of measuring out each of these here. So over here for the iron we have 5.00 mils, for the thiocyanate it's going to be 1.00 mils, and for the water we're going to be using 4.00 mils. So Taylor and Samuel, go ahead and make up those volumes please. As you can see, they're going to pour in a small amount from the beaker first, and then they're going to use pipettes that they're going to end up keeping in those beakers so that they don't end up causing cross-contamination. Isn't that right, Taylor and Samuel?
Yes.
Yes. Yeah, watch out for the tripod, Samuel. Try not to knock it. Now when they're doing this, they're trying to make it so that the meniscus is on the line here. Now remember, these are 10 mil graduated cylinders, so they can measure to 1 decimal place. Anything on the line there will be 0.0. Would you take that pipette out of the and put it in the beaker please? There we go. And Samuel, could you take that other pipette that you used for the iron and put it in the iron beaker, please? Thank you.
It's just one.
Yeah. Now if we keep these segregated, I don't really see any problem with taking them out and putting them back in. If there's a problem getting 1 milliliter in, can you see the one?
Yeah, you can. I just
okay, alright, okay. You can always take it off the bottom if you need to, but hopefully it won't be necessary to do that. Okay. So I will remind you about the proper technique with the pipettes here. Always keep them upright like this and don't lean them over, because they never did that, by the way, but what can happen is that the stuff can run into the bulb and we don't want to cause any contamination that way. So keep it upright or keep it in the beaker that you're going to be using as your solution. Alright, so now what they're going to do is they're going to pour all of these different solutions into a test tube. So would you do that please, Taylor? Thank you. I don't think the order is particularly important here. Now what we've done is we've made it so that the iron is actually in excess, so the SCN is the limiting reagent. It doesn't react completely, which is the entire point of the experiment, but it's allowing us to be able to figure out the equilibrium constant, because we're going to get varying volumes of each of these to get varying concentrations of product. So if you take a look at this product here, or the test tube, would you mind bringing it closer to the camera? There we go. You can see the color, it's a very, very lightish red color. And what's going to happen is, as we make these solutions, which I'll show you at the end, they're going to go in a color that's going to increase in intensity, and you'll see that at the end. So you can see the progression here of the colors as they go from light to darker. And Devon, would you please give that a bit of a stir? So I think it's a good idea to stir the solution. Would you mind moving your hand so that we can see it? There we go, that's good. Alright. So she's just using a stirring rod here to stir that around so that she can ensure that she gets proper mixing for the next step. We're using a Spectronic 200E here, And if you're using a different one at your campus, then you'll need to have your instructor show you how to use that. But this specific one has a screen that actually flips up like that, so I'd encourage you to use that. When you're on the home menu here, it's already gone through its initialization process at this point after it's been turned on. You go to the SPEC 200E modern interface by hitting the enter button here. The enter button is a little like the carriage return button down here. It's in the middle of these arrows. So click on that. Can anybody tell me what wavelengths we're going to have to use for this?
Let's say 474.
447? Okay, 447. So the current measurement here is at 675 nanometers, but we need a 447. That's going to be the optimal wavelength that will allow for us to get the maximum absorbance out of our solutions. So what I'm going to do is I'm going to use the down arrow here to get down here to the measurement here, measurement lambda. That's going to give us the wavelength. And what I'm going to do is I'm going to use this as my rough adjustment. This is this dial here. And taking this down as close as I can get to 447. But I won't be able to quite get there. Not with this adjustment anyway. So I do that, and I get down here, and we're at 450. Oops, there we go, 445. And then I can use the left and right arrows to take me up here. So now that's at 447. After that, I can hit enter and go back up here and go where it's got application and hit enter again, and then we're ready to take our absorbances. The first thing we need to do though is we need to calibrate for a blank, which is by adding water. Now the cuvettes are going to be in here, and these are the cuvettes. Now the cuvettes are interesting. They've actually got, I've got to find it on here. There we go. I'll try and bring this up close to it. You can see there's a little down arrow on one of the sides. This is going to be where you need the light to go through. So this is the side you don't want to touch, either the front or the back, where the arrow is, the down arrow there is on top. Can I please have a Kim wipe, Samuel? Right, thanks. Always use Kim wipes to wipe these down. This will get rid of any of the fingerprints that might be present. Don't use a straight paper towel. They'll tend to scratch up your cuvette. Always hold it on either side of the arrow. Could I please have the water? So I'm going to put some water in here. Just going to fill it fairly close to the top. There we go. I'm going to stick it in here, making sure that the arrows are pointing where the light's going to run, which is going to be in this direction right here. The next thing I want to do is I want to zero it, and I do that by hitting the 0.00 button, which is in the middle here. Now it takes a little time. It says performing auto zero at the top. And then you can see the absorbance now is 0.00. So now I'm going to take this out. I only need to do that once. And now I can use the cuvette now to start doing my solution. So Samuel, I'd like to see you do a solution, please. I'll close this for now. And what Samuel's going to do is, do you see where the arrow is?
Yes.
Okay, good. So he's holding it on either side of the arrow, which is good. And now he's going to take his first solution and he's going to pour it in. Taylor, would you mind getting a beaker for waste, please? Now Samuel's going to fill that, but he's not going to take the absorbance of it straight away. What he's going to do is this is to wash it out. Okay.
It doesn't need to be filled all the way up.
It will need to be filled all the way up when you're ready, yeah. But not for the washing part. Would you please pour that out?
Oh, okay.
So I recommend doing this a couple of times, just filling it up and then pouring it out. In between these solutions, you can also do a single rinse with just straight water as well. But I always like to rinse things out with what I'm putting in it. So that's what Samuel's doing right now. He's just rinsing it out. Now he's
enough? We may not have enough, right?
now you'll be good.
Okay.
Yeah, that's all you need to do.
Okay.
So could you bring it closer? Right. So he's going to pour it a little bit down. There we go. So now he's going to pour in that solution there. He's just rinsed it out a couple of times already. You don't want to do too many rinses because otherwise you won't have any solution left. Alright, is that close to the top? Say about maybe a centimetre from the top is ideal, I think.
Yeah, then we're close.
That's good. Alright. So now go ahead and stick it in. And you can see we get an absorbance value that comes up here. It should be pretty clear what it is. It may take a second to stabilize, but it should be alright. And that's it. You just read that absorbance value off and then do the next one. So what he's going to do is he's going to go ahead and take that out now. Now he's going to empty it, and now he's going to rinse it out with some water. Maybe do a couple of rinses with water. And then what he's going to do is he's going to do 2 rinses with the next solution and then repeat the process.